welcome back to my channel Physics Form 5 KSSM. Continue Chapter 1 Forces and Motion 2 on topic 1.4 Elasticity Part 1. In this video, I will discuss two learning standards. The first one is describe elasticity. The second one is communicate about the law related to force F and extension of a spring X. What is elasticity? Elasticity actually refers to property of material that enables an object to return to its original shape and size after the force applied on it is removed. Look at the example here. We have some examples of object, spring, sponge. Maybe you have in your mind other example of object that have same characteristic as this object shown here. Okay, let's look at some example. You can watch this video so that you can get the idea about the concept of elasticity. Okay, let's say we have a spring here. Okay, so we can draw out the original length of the spring. Now we apply force to stretch the spring. So you can see the length increase, or you bend it, okay, or twist it. What happens when the force applied is removed? We can check what happened to the spring. So you can see it returns to its original length and shape. So the spring shows the property of elasticity. We have another example like sponge. You can compress the sponge, press on it. You can twist it. You can see the shape change. You can squeeze it. But when you remove the force, it returns to its original shape and size. Another example is rubber band. So we can record initial size, maybe its length. Let's apply force so that to stretch the rubber band. So you can see the length increase. When you remove the force, it returns to its original length. If you look at the definition of elasticity, the three examples of materials shows property of elasticity. Means they are elastic material. Shape and size. How about this one, plasticine? You look at the initial shape of plasticine. Use your thumb, press on it. So you can see when you remove the force, the shape already changed but does not return to its original shape or size. Meaning plasticine does not show elasticity property. This is not elastic material. Okay. So what we can say about this one, the spring and the sponge, it returns to its original shape or size when force applied is removed. Thus, we call it elastic material. How about the plasticine? The shape and the size change after the force is removed. You can see from here stays deformed even after the force is removed. So this one, we call it non-elastic material. So it does not return to original shape or size when the force applied is removed. Okay, you can search more examples on this elastic material. Okay, let's look at relationship between force and extension of a spring. Okay, so in this topic, actually we will focus on spring because spring is one example of elastic material. We can carry out experiment by using a spring in order to find a relationship between force and extension. The law there is a state that relate between force and extension is Hooke's law. What is stated by Hooke's law? Hooke's law states that the extension of a spring is directly proportional to the force applied on the spring provided elastic limit of the spring is not exceeded. What is the meaning of this statement? Okay, let's see. We have carried out an experiment to show relationship between extension X and force applied. Before that, let's look at some definition of the terms involved. This is a spring without load. The length of the spring without load we label as LO. This is original length of the spring. Let's say we hang a load here. Okay, the load here, the weight is equals to mass times G, mg. So the force applied here is weight of load. The force applied causes the spring to stretch. So the new length of the spring with load we mark as L. The difference in length L minus LO is known as extension of the spring. So what you do, you repeat the experiment by using different masses of load, then record the value of X. With the data recorded, we can plot a graph of X against F. Based on the result of the experiment, when we plot a graph, we get a straight line passes through the origin. So the result shows that X is directly proportional to F. So we get this relationship, X directly proportional to F, or we also can write as F directly proportional to X. Thus from here we get this equation or this formula, F equals to Kx, where F equals to applied force, X is extension of the spring, K is spring constant, or also known as stiffness constant of a spring. So this formula, F equals to Kx, is the formula for Hooke's law. If we go back to the Hooke's law just now, which states that extension of spring is directly proportional to the force applied, provided the elastic limit of the spring not exceeded. What is the meaning of word elastic limit? You look at this graph. Let's say we have done the experiment, repeat the experiment a few more times until we get this graph. After a certain value of weight that hung to the spring, you can see the line of graph become curved, no longer straight line. If the line become curved, meaning it does not obey Hooke's law anymore. So Hooke's law is not valid here because Hooke's law always stated that x directly proportional to f, where the graph should be straight line. So what does this mean? The curve one. The curve one shows that the spring already lost its elasticity. Meaning, after this point, when you apply the force and you remove the force, the spring cannot return to its original length because this part already exceeds the elastic limit. So where is the elastic limit? So actually, elastic limit we can find from the graph is the end of a straight line graph or the starting point of a curved graph. So what is elastic limit? We can define as the maximum force that can be applied before the spring loses its elasticity. Let's say if the force here is 100 Newton, meaning for the spring you cannot apply force more than 100 Newton. If more than 100 Newton, meaning the spring will be spoiled. Okay, that is what's stated by Hooke's law. That's why there must be this condition, elastic limit not exceeded. Okay, then only you can get a straight line passes through the origin. Okay, analysis of graph of force against extension of spring. Let's say we can also plot a graph of F against X. What we can get from the graph. Analysis of graph, you still remember, we will discuss about the gradient, the area under the graph. Meaning what information that we can get from the graph. Okay, so this is F against X graph. Let's look at the gradient of the graph first. Let's say the value here is A and the value here is B. Gradient of the graph of F against X we can determine by drawing a triangle below the line. We can refer to this triangle. So the gradient equals to B divided by A, or B minus 0 divided by A minus 0. B is F, so the unit is Newton. A is X, so the unit is meter. Thus we get B over A Newton meter to the power negative 1. Okay, let's check Hooke's law. F equals to Kx. Let's say we take this point. That is, when X equals to A meter, force applied equals to B Newton. From Hooke's law, K equals to F divided by X. F is B Newton, X is A meter. Thus we get B over A Newton meter to the power negative 1. Okay, what we can see from here. You can compare the value of gradient and the value of K that we get here. We get same value. Look at the unit also the same. So what we can say about the gradient of the graph? So this shows that gradient of the graph F against X actually equals to K, or spring constant, or also known as stiffness of spring. So in order to determine the spring constant, we can determine by calculating the gradient of the graph F against X. Okay. Okay, second, we want to discuss about area under the graph. We still refer to the same graph. Let's see area under the graph until X equals to A meter. So this shaded area represents area under the graph. So how to calculate the area? The shape is triangle. So we use formula of triangle. So half times A meter multiply B Newton. So we get half BA Newton meter. The unit Newton meter is equivalent to joule. So the unit for joule actually is what? If you still remember, joule is for work done or energy transferred. Okay, let's look at the definition of elastic potential energy EP. Here should be S. Elastic potential energy EP. So elastic potential energy EP equals to work done to stretch the spring. Okay, as you can see here from the graph, we don't have a constant force. That's why force here we use average force. That is 0 plus F divided by 2 times extension X. Thus we get half F Newton X meter equals to half Fx Newton meter equals to half Fx joule. So elastic potential energy, the unit of course joule. When you calculate the area under the graph, you also get the unit here is joule. Thus, area under the graph represent elastic potential energy EP. Okay, so in order to determine elastic potential energy stored in a spring, you can just calculate area under the graph. We also can use another formula for elastic potential energy. So just use EP equals to half Fx, then use Hooke's law, F equals to Kx, you substitute here. And then you can simplify, you will get EP equals to half Kx squared. Okay. If you look at carefully, elastic potential energy, the unit is joule, meaning SI unit. So when you use the value of X to be substituted into this formula, make sure unit for X must be meter. Okay, or sometimes given centimeter, millimeter, you need to convert to meter. Then only you substitute into this formula elastic potential energy, because we want the final unit to be joule. Okay, so remember, for this graph F against X, the gradient of the graph equals to K and area under the graph equals to elastic potential energy EP. Now we want to discuss more about spring constant K. What factors that affect the value of spring constant K? There are 4 factors here. Material of the spring, length of spring, diameter of spring, thickness of spring wire. You can refer to this picture. When we talk about material, maybe the spring is made of steel or made of copper. Okay. Second, about the thickness of the spring wire. The same material steel, but we use different thickness of spring wire. Ini guna wire lebih tebal banding ni. Same diameter of spring. Okay. And this one use different diameter of spring. Okay. And this one use shorter and longer, meaning different in length of spring. Okay. So how are these factors affect value of K? Now we want to discuss one by one the change in the factor and effect on the value of K. Let's look at the first one, different material use. What happened to the value of K? The difference in material will produce difference in K. If you compare steel and copper, you can get K for steel is larger than K for copper. If you still remember, just now we have mentioned that K is spring constant or represents stiffness of the spring. When we talk about stiffness, it's more about the hardness of the spring. Okay? So the larger steel has a larger value of K compared to copper, meaning steel is stiffer than copper. Length of spring. When we use longer spring, it produces smaller value of K, meaning become less stiff. When we use larger diameter of spring, it also produces smaller value of K, or also less stiff. Okay, the fourth one, thicker spring wire. This one produces larger value of K, meaning become stiffer. Okay, so all these are the factors that affect the value of K. The larger the value of K, the stiffer or the harder the spring. What is the meaning of stiffer? Meaning not easily extend or produce smaller extension. So this one is based on Hooke's law formula. So we get K equals to F divided by X. The relationship between K and X is inversely proportional, meaning the larger the value of K, the smaller the extension of the spring. Okay, I will stop here for now. I will continue in my next video about solving problems involving force and extension of a spring. Okay, that's all. Bye.